Welcome everybody to the second part of chapter 14. In the next part, I would like to talk about the uncovered interest rate parity condition, so the UIP condition. More or less, it is the case that the investor has the same investment problem as in the CIP part. So the investor can invest either at home or can invest abroad. The main difference is that now the investor does not hedge for the exchange rate risk, so that the forward rate will not play a role anymore. So in this whole section, it will be the case that the forward rate will not pop up. Since the investor does not use the forward rate, the investor has to build expectations in period T with respect to the spot rate in period T+1. So the investor builds expectation in the period T for the period T+1. Everything else is the same, so that in the end, we once more can derive a relationship between the interest rate differential on the left-hand side of equation 6 and on the right-hand side of equation 6, there is the relative change in the exchange rate, and here like the expected one. So the expected change in the exchange rate in relative terms, in percentage terms, has to be equal to the interest rate differential. In some textbooks, you find equation 6 prime, where we have on the left-hand side the domestic interest rate and on the right-hand side the foreign interest rate plus the expected change in the exchange rate. So we can get from equation 6 to equation 6 prime by just writing the foreign interest rate on the right-hand side of this equation. Everything else is completely the same as in the CIP part, so we can relatively brief how equation 6 or equation 6 prime are derived. A big question is whether UIP holds. So to some extent, the UIP theory can be regarded as an exchange rate theory. The big question is, does the exchange rate develop according to the interest rate differential? Is it really the case that the relative change in the exchange rate is related to the interest rate differential? What is the relationship between this fraction and the interest rate differential? In the textbook, a test is performed with some empirical data. The domestic country is Japan, so R is the Japanese interest rate. The foreign country is Australia, so R star, this is the Australian interest rate, and the exchange rate E is the amount of yen we need to buy 1 Australian dollar. So let's have a look at this picture here, where we can see two lines over time. There is a red line, which is almost horizontal. Like you can see here, a little kink in this time period, but the red line seems to be completely horizontal, equal to 100. Then there is a blue line, which reflects the Australian dollar. And now we need to know whether this figure is related to like equation 6 or equation 6 prime. And I think that this figure is related to equation 6 prime. So the red line, this is R, like the interest rate in yen, and the blue line represents the right-hand side of equation 6 prime. It is related to the Australian interest rate as well as the change in the exchange rate. Why is this curve completely flat? So why is it a horizontal line? So we could think about that the Japanese investment is normalized to 100, but this is not the case. The red line is horizontal because the Japanese interest rate was already equal to 0 in 2003, 2004, 2005. So Japan got in the crisis in the second part of the 1990s, and the Japanese central bank reduced the Japanese interest rate to the level of 0. And then, of course, in case you invest 100 yen and the interest rate in Japan is equal to 0, then it will be the case that you stay at the level of 100 yen. What about the blue line? It seems to be the case that the interest rate for Australian dollar is positive. And like in the first year, the blue line is going up by 25%. But this does not imply that the Australian interest rate is 25%, but it's the case that also the exchange rate movement plays a role. When we look at this relationship over time, it is the case that the blue line is going up, while the red line is completely horizontal. But according to equation 6, it should be the case that these two lines move in tandem, which is not the case. So this is a first hint that the UIP theory does not hold for the two countries which we are examining here and for the time period under investigation. So the blue line and the red line, they move not in tandem, and therefore UIP does not hold. What's going on in this time period? The figure stems from a focus box which is called carry trade. What is a carry trade? A carry trade is an investment strategy where you borrow liquidity in a currency where the interest rate is low. Then you walk to the foreign exchange market. You are exchanging this liquidity into a currency where the interest rate is higher. So carry trades for this country pair implies that it is a good idea to borrow liquidity in Japanese yen, because here the interest rate is equal to 0. It doesn't cost anything to borrow Japanese yen. Then you walk over to the foreign exchange market. You are supplying yen and you are demanding Australian dollar, so that in the end you can invest in Australian dollar. This implies that in this time period here from 2003, 2004, 2005, in this time period, the demand for Australian dollar should be high because a lot of investors are performing these kind of carry trades. So they are getting liquidity in Japan, they are borrowing in Japanese yen, and then they are demanding Australian dollar. Therefore, it should be the case that when the demand for Australian dollar is high, the US Australian dollar should appreciate while the Japanese yen should depreciate. Let's check whether this is indeed the case. Yes, from 2003 onwards, it is the case that the exchange rate is going up. So here we have the nominal exchange rate, the amount of Japanese yen in order to buy 1 Australian dollar, and the curve is going up, which implies that the Japanese yen is weak and the Australian dollar is strong. So this increase of the blue line is not only driven by the positive interest rate in Australian dollar, so R star is still positive, but it's to a very large extent also driven by the relative change in the exchange rate. You can see here that the exchange rate is increasing quite tremendously in the year 2003 from the level of 70, let's say, to the level of 84. This is a 20% increase of the exchange rate. So this increase from 100 to 125 is to this 25% difference is caused by 20% the change in the exchange rate and 5% a positive interest rate in Australian dollar. What happens later on when we look at this time period here? You can see a sharp drop of the blue line. Why is that? Let's check how the exchange rate developed in this time period. You can see here that the exchange rate first is increasing from the level of 70 yen per Australian dollar to the level of 100 yen per Australian dollar. So a very sharp appreciation of the Australian dollar. But then in 2008, it is the case that suddenly the exchange rate plummets. In a very short time period, the exchange rate decreases from the level of 100 to the level of 60. Why is that? It is the case that a lot of investors, they are invested in Australian dollar. They have a short position in Japanese yen, they have borrowed in yen, and they have a long position in Australian dollar. So they switched the money, they switched the yen amount into Australian dollar, and it is the case that they invested in the Australian interest rate. So now a lot of investors are invested in Australian dollar, but suddenly there is a financial crisis, and a lot of investors, they would like to reverse their investment decision. They would like to sell Australian dollar to pay back the loan in Japanese yen. And of course, in this time period, there is a rush to the exit. A lot of investors try to get rid of this position. They want to unwind their position. So there is a huge demand for Japanese yen and a huge supply of Australian dollar. This is causing like this very tremendous, sharp appreciation of the Japanese yen. And this causes also this plump of the blue line. Great. We started to look at this relationship motivated by equation 6 prime. We wanted to find out whether the left-hand side, like the yen return, is equal to the right-hand side, the Australian dollar return. This doesn't seem to be the case, so this relationship does not hold. We looked at this graph and saw that the two lines are not moving in tandem, and therefore this is a first hint that the UIP theory does not hold for the two countries under consideration and the time period investigated. In the next part of the lecture, I would like to come up with a test procedure. How can we test the UIP theory by performing a regression analysis? In the first step, it is very important to clarify the theory. What does the theory tells us? Here, I would like to look at a hypothetical example, and let's assume for the moment that UIP holds perfectly. So we assume that equation 6 holds perfectly. If this is the case, we should have a 101 relationship between the interest rate differential and the relative change in the exchange rate. Let's assume that in January 2003, the interest rate differential is equal to minus 5%. In case that equation 6 holds perfectly, it should be the case that also the exchange rate develops by minus 5%. Let's assume that in February 2003, the interest rate differential is minus 10%. How should the exchange rate behave afterwards? The exchange rate should also decrease by minus 10%. In March, let's assume that the interest rate differential is 0, and then also the exchange rate should not change subsequently. In April 2003, the interest rate differential is equal to 5%, and here also the exchange rate should increase by 5%. Let's transfer this kind of data into a scatter plot. So the first observation, we said it's -5, and also the exchange rate should decrease by 5. The next observation, it was the case that the interest rate differential was a -10, and also the exchange rate should decrease by 10 units. The next observation, the interest rate differential was equal to 0%, and also the exchange rate did not change afterwards. In April 2003, the interest rate differential was a positive 5%, and also the exchange rate increased by 5%. So you can see here in the right part of the Excel file the relationship between the interest rate differential on the horizontal axis and the relative change in the exchange rate on the vertical axis. This is a scatter plot, and when you now would run a regression analysis, it should be the case that the regression line runs through the origin, so the intercept should be equal to 0, and the slope of this regression line should be equal to a positive 1. This is very important. So in case that the theoretical UIP relationship holds, the intercept should be equal to 0, and the regression line should have a positive slope, and the slope should be equal to 1. This helps a lot when now we come up with a regression equation, and also when we derive our hypothesis. So, equation number 6 gives us the regression equation. We put the interest rate differential on the horizontal axis. So the interest rate differential is the explanatory variable, and we want to explain the relative change in the exchange rate, which is given on the left-hand side of this regression equation. We want to estimate alpha, and we want to estimate beta. Alpha, this is the intercept, and beta is the slope of the regression line. We have two pairs of hypotheses, and it's very important that we write down these hypotheses. And it's a pair of hypotheses. So we have to write down the null hypothesis and the alternative hypothesis. So the null hypothesis with respect to the intercept is alpha is equal to 0, and the alternative hypothesis is alpha is unequal to 0. With respect to beta, with respect to the slope parameter, we said in case that UIP holds, then beta should have the slope of 1. Beta should be equal to 1. And the alternative hypothesis says that beta is unequal to 1. When we have written down the hypothesis in this way, we know that we want to perform like a two-sided test. In my lecture, we always want to test on a 95% confidence level. We always assume that we have enough observations so that the normal distribution is the appropriate choice, and hence the critical t-value in our lecture will always be equal to 2, or in case that you want to be precise, the critical t-value is 1.96. I have opened an Excel file, and in this Excel file you can see some information about the exchange rate, some information about the interest rate of the yen. So in column number D you can see the yen interest rate, and in column number E you find the information for the Australian dollar interest rate. So we want to test the UIP theory, and hence it is important that in a first step we compute the interest rate differential. So we have to compute the interest rate differential, and here it's also very important that we keep the time index in mind. So please focus on the time index, T and T. So the information in time period T are given in row number 2. So yen interest rate is given in D2 minus the Australian interest rate given in E2 gives us the interest rate differential. I press the return button and we'll get the result. So the yen interest rate minus the Australian interest rate, the interest rate differential is a negative 6.37%. Now I would like to copy this information down. So I once more go to cell number F3. And when I go to the right lower part, then the big white cross will become a small black cross. When I make a double click on this part, then I compute the interest rate differential for the whole time period. In cell number G3, I would like to compute the relative change in the exchange rate. Also here, it is very important that you keep the time index in mind, that you have a focus on the time index. In the first step, I have to set the parenthesis. Then I'm referring to cell number C3. I'm subtracting the information in C2. I close the brackets and I divide through the information in C2. So the formula which is used in cell number G3 is equal to, in brackets, C3 minus C2 divided by C2. This is the relative change in the exchange rate. Also here, I want to copy this information down. So I'm performing a double click on the right lower part of the cell and the information are computed all the way down. Now I can mark the area with the interest rate differential and the relative change in the exchange rate, and I would like to perform a regression analysis. In the first step, I want to create a scatter diagram. So I mark this area where all the data are with respect to the interest rate differential and the relative change in the exchange rate. Then I go to Einfügen, Insert. I'm using a scatter diagram, Punkt XY or XY scatter, and I'm taking the first one. So in the next step, I will format this diagram a little bit. And what is very convenient is this Schnell layout, this fast layout option. So I'm pressing fast layout, Schnell layout, and I'm using layout number 9, third row, third column. Here I get already like regression line, which is included here. I try to make it in red ink so that you can see it a little bit better. So you can see here my regression line, and there are also already with this fast layout number 9, you can see the regression results. I can also give some titles to the horizontal axis. Here we have the interest rate differential, and on the vertical axis we have the relative change in the exchange rate. And what we expect is, of course, it should be the case that the dots are located on a regression line which has a positive slope and goes through the origin. But when we look at this regression line here, it is the case that this regression line has a negative slope. It has a negative slope of minus 1.1283. This is a slope, and the intercept is estimated to be negative, but relatively close to 0. The R squared of this regression line is pretty low, only equal to 3%, so a very low R-squared. So in the first step, it is the case that I always perform this kind of graphical analysis. So I'm creating a scatter diagram and I'm plotting the data. In the next step, we would like to perform a real regression analysis so that we also get information about the standard errors and the confidence intervals. How is that performed in Excel? In a first step, I'll go to Daten, Data, then I'll go to Data Analysis, Datenanalyse, and here in the lower part of this menu you find a link to the regression. So Y variable, the Y variable, this is the dependent variable, the relative change in the exchange rate. And here I'm marking the whole area from G2 until the end. So I'm including row number 2, which has a label. So from G2 to G92, this is the Y part. Then the X part, this is the explanatory variable, the interest rate differential. Also here I'm including row number 2 from F2 to F92. Then I'm making a check here at Beschriftungen, at label, to tell Excel that the first row contains a label. Then I press the OK button. I get this kind of information here. I'll try to format this information a little bit so that it becomes a little bit more readable. So you know already that the R-squared is pretty low, only equal to 3%. You also have seen the intercept. So you know that the intercept is close to 0, and you also know that the slope is equal to a negative 1.1. So these information here, the coefficients as well as the R-squared, they should be completely identical to this information in the scatter plot. It has to be 100% identical, else you made a mistake, either by creating the scatter plot or when running the regression. Here we also get information about the standard error and the confidence interval. And now I'll switch back to the slideshow and come up with an interpretation of these regression results. Now I will switch back to the slideshow and come up with an interpretation of the regression results. I think that this assignment is very important, and you should also download the data set and you should try to replicate these results. The regression results are once more given on slide number 37. In the first step, we want to find out whether the one or the other hypothesis has to be rejected or whether this is not the case. We can do that by either performing a t-test or we can have a look at the confidence intervals. And in the first step, I would like to look at the confidence interval. Let's have a look at alpha. In our hypothesis, we claimed that alpha is equal to 0. Now we have to check whether the 0 is included in this confidence interval, yes or no. Yes, the 0 is included in this confidence interval because the lower bound of the 95 confidence interval is at minus 0.13 and the upper bound is at a positive 0.01. So the claimed value of 0 is included in the 95% confidence interval. We cannot reject the null hypothesis. What about beta? We claimed that beta is equal to 1. The lower bound of a 95% confidence interval is at minus 2.4 and the upper bound at 0.14. So the 1 is not included in this confidence interval here. Therefore, the conclusion has to be the claimed value of beta is not included in the 95% confidence interval. We have to reject H0. The empirical evidence is not in line with UIP. Beta is estimated to be negative but should be equal to 1. So beta is significantly different from 1 on a 95% confidence interval. UIP does not hold for the currency pair we were looking at and the time period analyzed. So the interest rate differential is not an unbiased or is not a good predictor of the subsequent change in the exchange rate. We have to reject the UIP theory on the basis of these empirical results. On slide number 38, we based our decision whether to reject a null hypothesis or not on the confidence intervals. Another idea is that we could perform like a t-test and base our decision on the results of a t-test. The final decision will be the same, so it's irrelevant whether we perform our analysis on the basis of a confidence interval or on the basis of a t-test. However, like in the exam, it might be the case that you are explicitly asked to base your results on a confidence interval or to base your decision on a t-test. So it's also very important that you know how a t-test is performed. So in the following, we'll come up with some estimated t-value and we compare the estimated t-value with the critical values. So first question is how to compute an estimated t-value. How do we come up with the estimated t-values? So the formula for the estimated t-value is as follows. The estimated coefficient, like the coefficient which stems from the regression analysis, minus the claimed value, the value we claimed in our hypothesis, divided by the standard error, and the standard error also stems from the regression analysis. So when it comes to the coefficient alpha, so the intercept, we claimed in our hypothesis that alpha should be equal to 0. The estimated coefficient is a negative 0.0619. We subtract the claimed value of 0 and we divide by the standard error. So the estimated coefficient and the standard error, they stem from the regression results. Like here you can see these two values, the coefficient and the standard error. So in the end, the estimated t-value is equal to a negative 1.70. And this is a value we also have seen before, like you can see here in the regression results, the t-value of a negative 1.70. Now you know how this value, like this estimated t-value, is computed. Let's also compute the estimated t-value for beta. We claimed in our hypothesis that beta should be equal to 1. Therefore, the formula for the estimated t-value is equal to, like the estimated coefficient, a negative 1.1283 minus the claimed value of 1 divided by the standard error gives you a negative 3.33. It is a case that you have not seen this value before. Let's go back to the regression results. In this table, you'll find a t-value which is equal to minus 1.77. So it seems to be the case that this t-value estimated by Excel is not appropriate. How did Excel computed this t-value. It is just the estimated coefficient minus 1.1283 minus 0 divided by the standard error. So when you divide the coefficient by the standard error, you get this estimated t-value. But this estimated t-value here is wrong. It is not related to our UIP theory. So the default option in Excel is that Excel always tests whether a coefficient is equal to 0 or not. In a lot of assignments, it will be the case that this is helpful, but not when it comes to testing the UIP theory. Here we want to test whether beta is equal to 1. Excel doesn't know that we are working with the UIP theory, and therefore we cannot rely our decision on this estimated t-value of a negative 1.77. We computed already the right t-value, which is a negative 3.33. On slide number 39, we just showed how to compute the estimated t-value. On the next slide, I will tell you how you have to interpret the estimated t-value. You have to compare the estimated t-value with these two critical values. In case that an estimated t-value is in this range, the conclusion has to be do not reject H0. In case that the estimated t-value is larger than 1.96 or larger than 2, or in case that the estimated t-value is smaller than -2, then the conclusion has to be reject H0. What does that imply for our regression results? So here, with respect to alpha, the estimated t-value is a negative 1.70. So we are here in this part of this graph, and hence the estimated t-value does not pass the critical value, and the conclusion is we do not reject the hypothesis that alpha is equal to 0, so alpha is equal to 0. What about beta? There, the estimated t-value is a negative 3.3. So we are in this part of the graph, and hence the conclusion has to be we have to reject the hypothesis that beta is equal to 0. Students sometimes have problems to come up with the right conclusion. When it comes to a hypothesis test, it is either the case that we reject the H0 hypothesis or we do not reject the H0 hypothesis. This does not imply that we are accepting a hypothesis. It does not imply that we are accepting the alternative hypothesis. And it's also the case that we are not rejecting the alternative hypothesis. So, like all our conclusions have to be as follows. We do not reject the null hypothesis, or we reject the null hypothesis. Please keep that in mind. A lot of mistakes are due to this kind of wording mistakes. Okay, so let's conclude. We have performed a regression analysis related to the UIP theory. According to the theory, it should be the case that the slope of this regression line should be equal to a positive 1. But the slope of the regression line is estimated to be negative. It's a negative 1. And this is not in line with our theory. Therefore, we have to reject the UIP theory based on these results. So we are rejecting the UIP theory for the two countries or the currency pair involved, and also only for the time period analyzed. We started to look at this relationship by a page of the textbook. Here, once more, on page number 345, you can see the initial graph we used to come up with this kind of empirical evidence. When you look at the lower part of this textbook page, when you look into a footnote, it is the case that here we are related, or a reference is made to a study published by Chinn. Let's have a look at this study of Chinn. The study of Chinn is published in the Journal of International Money and Finance, which is a very good journal. It's published in the year 2006. The article has a title, "The Partial Rehabilitation of the Interest Rate Parity in the Floating Rate Era, Longer Horizons, Alternative Expectations, and Emerging Markets." So when you look at this title and you read the words like a partial rehabilitation of the interest rate parity, you have to infer from this title that something is wrong with the interest rate parity condition. So in 2006, something is wrong with the UIP theory, and the UIP theory needs a rehabilitation. This is very interesting because of the fact that also in our empirical analysis, we had to reject the UIP theory. When you read this Chinn article, like on page 9, there is a very interesting quote. So Chinn is referring to a study by Froot and Thaler published in the year 1990, and there Froot and Thaler, they talk about an average estimate of beta, which is equal to a negative 0.88. This seems to be very interesting because also in our regression analysis, we found a negative beta, which was equal to a negative 1, which is very close to this average estimate of minus 0.88. This is a very, very famous quote. You can find this quote in a lot of articles which are related to the UIP theory or tests of the UIP theory. So a very famous quote. Let's have a look at the paper of Froot and Thaler 1990. So Froot Thaler 1990, page 182. The important sentence is highlighted here. The average coefficient across some 75 published estimates is a negative 0.88. This result should be published by Froot 1990. A few beta coefficients are positive, but not one is equal to or greater than the null hypothesis of beta equal to 1. So here it is, we get the impression that Froot 1990, he was examining 75 different studies and he computed an average, and the average was a negative 0.88. But then if you look at this paper of Froot, which is an NBR working paper published in the year 1990, it is the case that there is nothing mentioned of this negative coefficient minus 0.88. It's also the case that in this working paper, Froot does not analyze 75 different studies. This is very interesting. It is interesting because Froot and Thaler in the year 1990 are citing a working paper of Froot, and this citation is wrong. It's so interesting because this is a very, very famous quote, as I said before. Like, you can find it in a lot of textbooks, you can find it in a lot of papers, but in the end it is the case that this is wrong. In the original source you find not 75 different studies, and the average of minus 0.88, you will not find it in this working paper of Froot. This is to some extent important when you write your bachelor thesis. Always try to find the original source, go through the literature and find the original studies. There are a lot of mistakes in the literature, and when you find such kind of mistake, then you can really score very high in your bachelor thesis. But let's go back to the Chinn paper. Like, we started to look at Chinn 2006, and it seems to be the case that the UIP theory needs a rehabilitation. On page 10, Chinn comes up with the following regression results. So he's also performing a regression analysis. On the left-hand side, we have the relative change in the exchange rate. And on the right-hand side, an alpha as well as a beta. And as an explanatory variable here, you can see the interest rate differential. They are performing this analysis for a lot of different countries in relation to the US. So the counterpart is always the US. And they are performing this regression analysis for 3 months interest rates, 6 months interest rates, and 12 months interest rates. In this table, you can only see the beta coefficient. So only the very interesting beta coefficient is given in this table. And look at that. It's negative for the Deutschmark, it's negative for the Japanese yen, it's negative for the British pound, it's negative for the French franc. Only the Italian lira shows a positive sign, but also here the estimated beta coefficient is not 1, but only equal to 0.5. For the Canadian dollar, the beta coefficient is a negative 0.5. When it comes to the 6 months horizon, it's also the case that all the beta coefficients are negative. One exception is Italy. Also, when it comes to the 12-month time horizon, all the beta coefficients are negative. Only for Italy, it shows a positive sign. So here in this table 1, Chinn is replicating like the main results of the UIP theory, that when it comes to regression analysis, beta is estimated to be negative. So our finding for the yen-Australian dollar relationship is completely in line with the empirical literature related to the UIP theory. So now I really think that you are prepared to read at least the first few pages of the Chinn article. You can read and understand the Chinn article, and you know what he is talking about. I think that this is a very big step for all of you, because I think for the first time we were using a theory. We used this theory and we derived hypotheses from this theory. We defined the hypotheses, and then we tried to contrast and confront the hypothesis with some results which stem from a regression analysis. So we were able to base our analysis and our conclusions on a regression analysis. According to our results, the UIP theory does not hold. We had to reject the UIP theory. And this is in line with the empirical literature. As you can see here, Chinn in the year 2006 published an article where it seems to be the case that the UIP theory needs a rehabilitation. Thank you very much for watching this part of the lecture. I think it's a good idea to digest and have a short break. The next part of chapter 14 will be presented in a separate video. Thank you very much. Have a nice day. Bye bye.